Good afternoon to all, my dear children. The last class we learned about what are the properties of colloids. I think that we have more than 13 properties. Some of the properties are we discussed. Today we have discussed about the optical property, kinetic property, and also the electrical property. The optical property is about the Tyndall effect. The 10th grade also we learn about the Tyndall effect. The scattering of light. Okay, the scattering of light is called about the Tyndall effect. Next about the kinetic properties about the Brownian movement. Brownian movement. The particles are possess certain ceaseless, chaotic, random motion. Yes, some of the properties are executed by these colloidal particles that we have discussed by Brownian movement was observed by Robert Brown. Okay, about the Tyndall effect. First, the Tyndall effect. It is about the scattering of light was discovered by what observed by Faraday. Okay, first was Faraday. Later, it was explained by Tyndall in detail. Okay, that is about the Tyndall effect. The next one is about the electrical properties, about the Helmholtz double layer. Helmholtz double layer. One is about the electrophoresis and another one is electroosmosis. Here the electrophoresis, otherwise called cataphoresis, is a very important question. It's a very, very important question. Electrophoresis, otherwise called cataphoresis. And also it is one of the indirect questions. How can you determine the charge of the solid particle? How can you determine the charge of solid particles? It's a very, very, very important question. Electrophoresis. Here, the migration of solid particles under the influence of an electric potential is called electrophoresis, otherwise called cataphoresis. Okay. The migration means movement. The movement of solid particle under the influence of electric potential. Okay, the movement of solid particle under the influence of an electric potential is called electrophoresis, otherwise called cataphoresis. Next is the last one is about the electroosmosis. Okay, here the movement of dispersion medium. Okay, here the movement of dispersion medium under the influence of electric potential is called electroosmosis. Okay, the movement of dispersion medium under the influence of electric potential is called cataphoresis. Anyhow, today I am giving that very important question for the assignment. Don't forget to learn this question. Okay, very, very important question. Electrophoresis, cataphoresis. We can be discussed one by one. Okay, please all of you take note. We can be discussed. My dear children, previously we discussed about the properties of colloids. Okay, properties of colloids. Here we discuss about the color, size. The colloidal solution are heterogeneous in nature, having two different distance space, filtrability, non-setting nature, concentration and density, diffusibility, qualitative property, shape of the colloidal particles. Everything we discussed. The next one is about the optical properties, kinetic property, especially the optical property means about the true solution, and about the kinetic property means about the Brownian movement. Okay, true solution means we are discussing about the Tyndall effect. Okay, optical property we have discussed about the Tyndall effect. Next about the kinetic properties we have to discuss about the Brownian movement. Okay, anyhow, one more property is called an electrical property about that Helmholtz double layer, electrophoresis and electroosmosis. These are the very important question. Just we can discuss about the optical properties of colloids. Okay, optical property. the optical property. We know that the colloids having optical property. Okay, the colloids have optical property. When a homogeneous solution is seen in the direction of light, it appears clear, but it appears dark. Okay, in the perpendicular direction. That means when we are passing a light, okay, one of the flashlight we are passing through one of the solution is, we can be say that it's a homogeneous solution. Homogeneous solution. That means when a homogeneous solution is seen in the direction of the light, it appears clear, but it appears dark in the perpendicular direction. But the case of colloidal solution, when we see a colloidal solution, this is a colloidal solution. Colloidal solution. Here what is happening here means, when we passing the light through the colloidal solution, when we are passing the light through the colloidal solution, here it is scattered in all directions. Okay, because colloidal solution has some particles, am I right? Having some particles. Okay, it's scattered in all directions because it was absorbed by Faraday. Okay, who is absorbed here? Faraday. The first, this effect, one of the effect, the scattered in all direction, it is observed by Faraday. But the investigation are made by Tyndall in detail. Okay, Tyndall in detail. Hence, it is called as, we can say it is called as Tyndall effect. Here, the path of can be visible by means of light. Okay, when we can say that the scattering of light. Okay, the scattering of light is we can be visible. So we are saying scattering of light. Okay. Okay, anyhow. One of the very important question about the Tyndall effect. What is that? We can be add a simple line about that. The scattering of light is called as Tyndall effect. Here, the colloidal particles absorb a portion of light and the remaining portion is scattered from the surface of the colloid. So, hence the path of the light made clear. Clear? So what is about the Tyndall effect? The scattering of light is called as what? Tyndall effect. It was observed by Faraday. It was observed by Faraday. But the investigations are made by Tyndall in detail. Okay. Hence called as Tyndall effect. Okay. This is about the Tyndall effect. This is only in the colloidal solution, not in the true solution. Okay. Anyhow, the next property we can discuss about that, the kinetic property. This is about the optical property. Okay, optical property. Don't forget that the optical property means that is what? Tyndall effect. Okay, scattering of light. Don't forget that the scattering of light is called what? Tyndall effect. Next one is about the kinetic property. That means Brownian movement, the kinetic properties. Okay, that is discovered by Robert Brown. Okay, about the kinetic properties. Next one is about the kinetic property. Kinetic property. Here, Robert Brown was observed that when the pollen grains suspended in water were viewed through an ultra microscope, they showed a random zigzag ceaseless motion. Here, when you're having some particles, here the particles are colliding to each other. Okay, one of the particles collide like that, colliding to each other. So he found that one of the motion. What is the motion we found that? What is about the random? Okay, don't forget that random. The random motion. Zigzag. Zigzag, and one more we can give. Zigzag, okay. Ceaseless. Ceaseless motion. Executed by the particles is called the Brownian motion. That is called a Brownian movement. Brownian movement of the colloidal particles. Clear? What is about the kinetic property? When the pollen grains suspended in water were viewed through an ultra microscope. Clear? When the pollen grains suspended in water were viewed through an ultra microscope, they showed a random zigzag ceaseless motion. This is called Brownian movement of colloidal particles. Okay. Anyhow, the colloidal salt particles are continuously bombarding with the molecules of the dispersion medium. This is one of the dispersion medium. Here, the salt particles are continuously bombarding. Okay, that means colliding. Okay, bombarded with the molecules of the dispersion medium. Hence, they follow as zigzag, okay, zigzag or random or ceaseless or continuous movement. That movements are called as what? Brownian movement. Brownian movement. Here, Brownian movement enables us. Here, three major important points. One is about to calculate Avogadro number. Don't forget that. The three important points. One is about to calculate Avogadro number. Second one is to confirm kinetic theory, which considered the ceaseless rapid movement of molecule. Third one is to understand the stability of colloids. These are the three points the Brownian movement enables to us. Okay. What is about the first one? To calculate Avogadro number. Sometimes the question may be asked like that. Right? The Brownian movement enables to us. Okay. First one is about to calculate Avogadro number. Second one, to confirm kinetic theory, which considered to ceaseless rapid movement of molecules. Okay, the third one is to understand the stability of colloids. Okay, anyhow, we can discuss one by one. First one, to calculate the Avogadro number. Already we learned about the Avogadro number. The second point is to confirm kinetic theory, which considered the ceaseless rapid movement of molecule that increases with increase in temperature. Second one, to understand, the third one, to understand the stability of colloids. That means, as the particles is continuous rapid movement, they do not come close and hence not get condensed. Okay, that is, the Brownian movement does not allow the particle to be acted by the force of gravity. Anyhow, the next one is about we can discuss the electrical property. Okay, electrical property. That means we have three important electrical property. One is about the Helmholtz double layer. The next is about the electrophoresis. The another one is about the electroosmosis. Okay, the three important electrical property. One is about the Helmholtz double layer. Okay. Here, what is about the Helmholtz double layer? electrical property. Helmholtz double layer. This is one of an imagine. This is one of an negatively charged particles. Okay, a negatively charged particles. Okay, negatively charged particles. The negatively charged particle is surrounded by positive charge. Okay, it is surrounded by positive charge. Positive charge. Here, the positive charge, here, the surface of the colloidal particle absorbs one type of the ion due to preferential absorption. Here, this layer is attracted by the opposite charge layer. Maybe this is the negative charge, this is about what? The positive charge. Am I right? This layer is attracted to the opposite charged ions, the medium. Hence, at the boundary is separated, this boundary is separated by two electrical double layer setup. Two electrical double layer. Okay, that means maybe positive or negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. Except, okay, here anyhow, at the boundary, here the separating of two electrical double layer setup. This is called Helmholtz double layer. Okay, we can say the combination of two layers. The two layers, that means one is positive and another one is negative. The combination of these two layers, we are saying that what? Helmholtz double layer. Helmholtz double layer. Clear? As the particles nearby having similar charge, they do not come close and condense. Okay, hence it helps to explain the stability of colloids. This to explain about the stability of colloids. Next is about the electrophoresis. Okay, what is about that? Electrophoresis. First, we shall be discuss about the diagram. First, the electrophoresis means first to draw the diagram. Okay. This otherwise we can say about the cataphoresis. Sometimes the question may be asked like that about the cataphoresis, like that we can be asked. Okay. The question may be one of the indirect question. How can we determine the charge of the solid particle? How can you determine charge of solid particles? Sometimes it may be asked like that, one of the indirect question. Okay. First of all, we are taking one U-shaped tube. One of the U-shaped tube. Okay. Here we are fixing two electrodes. One may act as an anode and another may act as a cathode. Okay. Anode is the positive charge and cathode is the negative charge. Am I right? Okay. Next we are taking colloids, which are the any one colloids we are taking. Okay, one of the colloid solid particles. Okay, one of the colloids we are taking colloid solution. Okay. Above we are adding some of the deionized water. Okay, in any other two ionized water. Deionized water. Okay. when we are in, uh, when you are applying electric potential, some slow voltage, maybe 100, maybe taken as a 100 watt like that, okay, 100 watt, we are applying here, due to the electrical supply, here migration of solid particles under the influence of an electric field is called as electrophoresis, otherwise called cataphoresis. Okay, first try to learn the definition. Here, the migration of solid particles. The migration of solid particles under the influence of electric field is called electrophoresis, otherwise called cataphoresis. Okay, anyhow, if the solid particles migrate to cathode, here suppose the migration may be occurring cathode or anode. Okay. Suppose here the solid particles are migrate to the cathode. Sometimes the level of the limbs, we have two limbs, am I right? Two limbs here. This is one limbs. Level of this limb will be rise. Okay. Rise means this solid particles possess a positive charge. Okay. Suppose we are trying to understand this one. The migration of solid particles under the influence of electric potential is called what? Cataphoresis, otherwise called electrophoresis. Okay. Here, if the solid particles migrate to the cathode, then they possess charge, positive charge. Okay. Here, migrate to the cathode, it possesses the positive charge. Sometimes, in another one condition, if the solid particles are migrate to the anode, okay, sometimes the solid particles are migrate to the anode, they have what charge? Negative charge. They have negative charge, okay? Try to understand the concept. The migration of solid particles under an influence of electric potential is called as what? Electrophoresis, otherwise called cataphoresis. Clear? Anyhow, the migration is important. Migration may be occur maybe in cathode or maybe in anode. The migration is occur in cathode. It is what? Positive charge. The solid particle contain positively charged particles. Suppose if the solid particles migrate to the anode, they have negative charge. Thus, from the direction of the migration of solid particles, we can determine the charge of the solid particles. From the migration, okay, due to the migration, we can determine the charge of solid particles, okay? Hence the electrophoresis is used for the detection of presence of charges on the solid particle. Only find out the charge of solid particle. Try to understand the experiment. First we are taking one of the U-shaped tube, am I right? U-shaped tube. Here we are taking some colloidal solution, some of the colloid solution. Okay, here's the colloid solution. Okay. Above we are adding a deionized water. Okay, deionized water. We are adding both the two limbs. Okay, both the two limbs. Okay, this also deionized water. We are placing here two electrodes. One is an anode and another one is a cathode. Okay. Already told you about the charge of the anode. Anode charge is about the positive and about the cathode charge is negative. Am I right? We are applying 100 volt. How much volt we are applying? Only 100 volt potential we are applying here. Here the migration will be takes place. Okay. Migration either may be in cathode or may be in anode as respect to the colloidal particles. If the colloidal particles have the negative charge, it is attracted by negative charge is attracted by positive electron. Am I right? Suppose the colloidal particles, it is about the positive charge, means it is attracted by cathode. Am I right? Yes or no? So any one of the limb may be raised. Okay, suppose the cathode limb rise means the anode limb will be false. Here, am I right? This side will be false and this side will be rise. Suppose it occur like that means the charge is positive, because positive is attracted by negative electrons. Positive is attracted by negative electrons. Okay, sometimes this colloidal particle is a negative charge. It is attracted by the positive electrons. So the level of the limb may be raised upwards. Okay, so it is a negative charge. As per the migration, we can explain about the charge of the sold particle. Charge of the sold particles. Okay, here our textbook having about that positively charged colloids and negatively charged colloids, and also electrophoresis diagram. Page number 95 have it, please. Draw the diagram. Anyhow, here some of the few examples. What are the few examples of charge of sold particles? Okay, here ferrihydroxide, positively charged colloids, aluminum hydroxide, basic dyes and hemoglobin, etc. These are all what? Positively charged colloids. Okay, here the negatively charged colloids means silver, gold, platinum, arsenic sulfide, clay, starch, etc. These are what? About the negatively charged colloids. Okay. Next about that electro-osmosis. Okay. Electro-osmosis, here the movement of dispersion medium under the influence of electric potential. Electro-osmosis, don't forget that. The movement of dispersion medium under the influence of an electric potential is called electro-osmosis. Okay, electro-osmosis. This is a very important question. Try to learn this question, my dear children. Electrophoresis and electro-osmosis, the very important question. Electro-osmosis, the movement of dispersion medium under the influence of electric potential is called electro-osmosis. Okay, what is about the electric osmosis? The movement of dispersion medium under the influence of electric potential is called electro-osmosis. What is about the electrophoresis? The migration of sold particles. Clear? The migration of sold particles under the influence of electric field is called electrophoresis, otherwise called cataphoresis. Okay. What is about the electrophoresis? The migration of sold particle under the influence of electric field is called electrophoresis, otherwise called cataphoresis. Here electro-osmosis, the movement of dispersion medium. Here medium is moving. Okay, the movement of dispersion medium under the influence of electric potential. Okay, here how can you first we can draw the diagram. Okay, we shall draw the diagram. Here we are taking a semi-permeable membrane. Okay, semi-permeable membrane. Here also taking two electrode. Anode, cathode. Okay. Semi-permeable membrane. Here first we are filled with water. Okay, we are filled with water. Here we are taking salt particles. Salt. Okay. Salt particles are there. Okay. This is about the water level. We are measuring the water level. Water level. We have to measure the water level. Okay. Now, this is about the, at least about the diagram. Here we have one, just one close one stopper like that. Okay. Anyhow, the soul is an electrically neutral. Okay. All of you know that one. A soul is an electrical neutral. Hence, this medium having an equal but opposite charge to that of dispersed particle. Clear? In medium carries an equal but opposite charge to that of dispersed particle. When soul particles are prevented from moving under the influence of electric field, the medium moves in the direction opposite to the soul particles. Okay. Here, now the medium is moving under the influence of what? Under the influence of an electric potential. Okay. Here, when the soul particles are prevented from moving under the influence of electric field, the medium moves in the direction opposite to that of the soul particles. Okay. This movement of dispersion medium under the influence of electric potential is called electroosmosis. The question may be asked, the 2-mark question. What is electroosmosis? Okay, the question is like that. 2-mark, I'll ask the 2-mark question. What is about the electroosmosis? The movement of dispersion medium under the influence of electric potential is called electroosmosis. Don't forget, please underline the line. The movement of dispersion medium under the influence of electric potential is called electroosmosis. What is about electrophoresis? The migration of soul particle under the influence of electric field is called electrophoresis. Okay, otherwise called cataphoresis. Okay, clear? Clear. Today we discuss about that very important point about that Tyndall effect. What is about the Tyndall effect? Scattering of light. Don't forget that the scattering of light is called Tyndall effect. Who is first discovered the Tyndall effect? That is about the Faraday. Okay, Faraday. Okay, but investigation is made by Tyndall in detail. So it is called as what? Tyndall effect. Okay, what is about the Tyndall effect? The scattering of light. Okay, is called Tyndall effect. Clear? What is about the Brownian moment? The colloidal particles are continuously bombarded with the molecule of the dispersion medium. Hence, they follow a zigzag random continuous movement. This is about what? Brownian movement. Okay, was discovered by Robert Brown. What? Observed by Robert Brown. Okay, very, very important question. Here, what are the 3 important points about the Brownian movement? First, to calculate Avogadro number. Second one, to confirm the kinetic theory which considered the ceaseless rapid movement of the molecules that increases with increase in temperature. Third one, to understand the stability of colloids. These are the 3 important enablers. Okay. Anyhow, the next one is about the electrical property, about that Helmholtz double layer. Okay. Helmholtz double layer. The surface of the colloidal particles absorb one type of ion due to preferential adsorption. This layer attracts the oppositely charged ions in the medium. Hence, at the boundary is separated, the two electrical double layers are set up. This is called Helmholtz double layer. These are the very important 3-mark questions. Okay. These are the 3 important questions. That Brownian motion, Helmholtz double layer. Okay. And about the electrophoresis and about the electroosmosis. Okay. Anyhow, electrophoresis is a very important question. So try to write this question for the assignment. How will you determine the charge of solid particles? Okay, that is what? That is what? Electrophoresis or cataphoresis. Electrophoresis or cataphoresis. One of the three more questions. Draw the diagram. Okay. I think that the page number 94. Page 94. Okay. 94. Electrophoresis or cataphoresis. Very important question. How will you determine the charge of solid particles? Charge of solid particles. The question is about page number 94. Electrophoresis or cataphoresis. The page number 94 and 95. Try to learn this question, my dear children. Okay. Okay. If you have any doubt, please call me. Thank you all of you. Thank you. Have a nice day.